Okay, so what we're going to look at today is transformations. This is what we're going to look at for the rest of the unit. This is the transformation form, so this is the general one that'll work for any function. When we start doing each function individually, letting them have their own unit, we'll look at the actual transformation form for each function, but for right now, we're going to stick with this. There are three different letters in here that are going to represent numbers, for our notation. So depending on what they are, that could move the graph left or right, up or down. It could make it thinner or wider. It just depends on what the number is and where it is in this notation. So if we look at that a value, if the a value is greater than 1, so we ignore the negative because no matter what we have, if it's negative, all that we know about it is that it's a reflection. So basically it turns the graph upside down. If the a value is greater than 1, so ignoring the negative, so even these, if the a value is greater than 1, it's a vertical stretch. That means the graph is going to look skinnier than it did before because it's increasing more quickly. If the a value is less than 1, so ignoring the negative, if the a value is less than 1, that is a vertical compression. That means that the graph is going to increase more slowly and the graph is going to look wider than it did before. The c value is going to move the graph left and right. Because that part of the notation has x minus c, when we have a negative c value and the graph moves left, it's going to have a plus. And that's because when we plug in that negative value, subtracting a negative is the same thing as adding a positive. Plugging in a positive value, there's nothing to cancel out that minus, and so it'll be x minus a number. So be very, very careful because it looks the opposite of what it actually does. So make sure that you're paying attention to the signs on there. X plus something goes to the left, x minus something goes to the right. At the end there, it has plus the d value, so the sign will be, it'll look like what it's supposed to do. Plus will go up, minus will go down. So here we have -2 f of x minus 4 . plus 5. So you're going to have to use complete sentences on your test. So we're going to do that here as well. So the graph is, we have a negative A value. So the graph is reflected across the x-axis. We could also say that it's vertically reflected. Those mean the same thing. The graph is also, because these are two separate things, vertically stretched by 2. We have x minus 4, which means the graph is going to move right 4. And our d value is 5, so it's going to move up 5. For number 2, we don't have anything out front, which means our A value is 1, and there's not going to be any stretches or compressions. Since it's a positive 1, there's not going to be a reflection either. We do have something happening over here with the C value. We have x plus 7 in there, and the D value is negative 1. So this time the graph is moved left 7 and moved down, because it's negative 1. For number 3, we've got an A value again. It's 2/5. There's no C value. And the D value is negative. The D value is negative 4. It's not letting me erase for some reason, so that's going to stay like this. Okay. So the graph is 2/5 is less than 1, so it is vertically compressed by 2/5. And moved down 4. Now what we're going to do is go the other way. So we're going to start with the description, and we're going to write the function notation from the description. So we want to write the function notation that describes the rational function. And again, does not matter what kind of function it is because we're just doing the general one right now. But we want to find the function notation that describes the rational function, which has been moved left 5, moved up 2, and reflected over the x-axis. It's been reflected smaller again, there we go, which means that our a value is negative. We don't know anything else about the a value, so it'll be 1. We know that the graph has been moved left 5, so inside those parentheses we're going to have x plus 5 because it's going left. And we know that it's going up 2, so the d value will be positive 2. Every single time we write the function notation, we will have all of these pieces that I've written here in the rainbow one. What's going to change is what we put in for A, C, and D. Now we can just, because the a value is 1, put a negative. If you want to write out the 1 to help your brain, do it. Does not change the value because of the 1. We'll have x plus 5, and then the plus 2 on the outside. So if you're asked to write the function notation, that's what you need to put it. This time we want to write the function notation that describes the cubic function, which has been vertically stretched by 4 and moved right 2. So it's been vertically stretched by 4. Doesn't say anything about a reflection, so it'll be positive 4. We know that the graph goes right 2, so it'll be x minus 2. And there's nothing about it moving up or down, so we don't have to worry about the d value for this one. A value is 4, and we're going to have x minus 2 there. D value is 0 since there's nothing there, so that's just going to be it. We don't have to put anything out there. Write the function notation that describes the exponential function, which has been vertically compressed by 1/4 and moved down 5. So this time it doesn't say anything about the graph moving left or right, which means we don't have to do anything with that c value. So when we end up doing this, we don't have to leave a space for a c because there's nothing happening with that this time. We do know that the a value is 1/4 because that's what it's being compressed by. And we know that it's going down 5, so that'll be a negative 5 on the end. Doesn't say anything about a reflection, so that A value will be a positive 1/4. Last one, write the function notation that describes the absolute value function, which has been vertically stretched by 3, reflected over the x-axis, moved right 8, and moved up 7. So we have a reflection this time, so our A value is negative. It's been vertically stretched by 3. Graph went right 8, so it'll be x minus 8. And then it went up 7. So reflection over the x-axis, vertical stretch by 3, right 8, and up 7. Okay, so that's all of them. There's extra practice in the folder if you need it, but that's all the examples we have.